Awesome, thank you. Hopefully you've all heard somehow about the remarkable efforts of Lisa Carne and her organization, Fragments of Hope, which is based out of Placencia, Belize. In this talk, I'm going to show you some data that's derived from time series like this movie I'm showing here of one of her sites. You can see over time the growth and sometimes breakage and decline of Acropora cervicornis and palmata in this site. And one of the questions I'm trying to get at here is how can we quantify this in a sort of rigorous way. So in 5 minutes, I can't possibly do the justice to the work Lisa's done over the last 2 decades, but this is just a brief overview. You can see some of the successes that she's done here. This is an image of, I don't know if I can point, maybe. So this, whoops, yeah. This is an image of coastal Belize here, and these, she started her work back in 2006 at Laughing Bird Cay National Park, which is down here, and you can see all these green dots are other sites where they've extended their work in the other years. There's some notable things here, like over almost 200,000 outplanted corals. An important one, documented spawning, documented recruitment of corals, so getting at things like the reproduction issue. I want to focus here at 5 sites at Laughing Bird Cay and Moho Cay. The ones circled in orange here are ones that we have pre-outplanting images for, as well as annual follow-up images. So those are the most interesting ones from this point of view. And so those are the ones I'm going to focus on here really quick. So hopefully everybody by now, we've talked about it quite a bit in this conference, is at least passingly familiar with the idea of large area imaging. And I think you'll get the idea of what's going on from this video. This is site Moho 2, and you can see how much of the site is covered with mobile rubble at the start of this time series. And over time, the growth of mostly of cervicornis here covers a lot of the area, but it also stabilizes the rubble. And so there's a lot less palmata in this site than at others, but there's a big colony up there in the upper right. So of course, one of the things that you can do from this imagery is estimate the percent cover of whatever you want, but in this case, I'm showing live coral cover at each of these sites. And what you can see is the dramatic increase of live coral cover at each of these sites over time. Lisa's actually shown this data before, so I want to show you something else. And that is something like a digital rugosity index, okay? So probably everybody's familiar with the idea of a chain or tape measure rugosity. We can do that virtually with these models. And the idea is to basically drape transects like this. Hopefully you can see. In these 2 examples, I have these orange lines here. And what's nice about these models is because we can actually register them one to another, you can get the same transect year after year, which is a challenging thing to do, in the field. But even if you do that, I'm just showing here three, for example, over a site like this, the values you get along an individual transect are quite variable. Right? It depends where you put that in this transect, the answer you get. And so the answer that I've come up with to deal with this, or at least the simplest answer, is to do lots of them. So here we've got about 50 of these transects drawn across the site. The spacing along each line is 5 millimeter spacing along each line, and the lines are separated by 20 centimeters. And we can compute a rugosity index for each one of these lines and then look at them sort of as an average by the site. And what you can see here, each of these boxes show the distribution of this rugosity index at each site. And there's some interesting things here. Like, first of all, a lot of these sites show a decrease in rugosity over 2014 to 2017. This is related to the passing of Hurricane Earl in 2016, which sort of flattened out the sites. But then there's been a large uptick in all these sites in the years past as these sites have stabilized and grown. And then finally, this one site, 23, you see, had very little change and was very slow to start at the beginning. And that's, I think, because this was the most rubbly of the sites. And actually, if you don't focus on the corals here, but focus on the background, you can see all of these individual rubble pieces actually moving around in the earlier years. And then as soon as they get actually stabilized a little bit, you see dramatic growth of coral over time. So to just kind of wrap this up, the visualization of this sort of rubble to reef process is really possible and dramatic with these photogrammetric time series. And we've seen before the success of Fragments of Hope in many of their metrics, but this topography index, this rugosity, adds literally another dimension to our ability to do that. What I've done here is very simple, but it's quantitative, and it shows you year over year what changes. We're going to see in the next talk kind of some more advanced ways to deal with this data, to treat it. But even with this very simple approach, you can see. And then, of course, the next step with something like this is to link these measures of benthic rugosity or roughness with shoreline protection, like we were talking about, like Andrew was talking about earlier. And so with that, my time's up, and I'll just thank everybody.